Okay, I'm sorry for the model. So, last lecture we discussed about Newton first law, and we say Newton first law, it is the law of inertia. What is the mean of inertia? It is the resist of the object to its state. مقاومة الجسم للموضع ماله. وقلنا بأن هناك علاقة. There is a relation between the inertia and the mass. If the mass is increase, so that means the inertia, it will be increase. If the mass is high, so that means the inertia is high. So the mass is low, so that means the inertia, it will be also low, because it is easy to move it with any applied force. And we say also, and we discussed also from Newton's first law about the law itself, and we make it into stages. Stage 1, and we say in this stage it is in rest. What it mean in rest? So there is no motion. So motion is equal to 0. If the motion is equal to 0, so the velocity is 0. The acceleration also is 0. So that means the object in balanced or in equilibrium. How I find this stage? When the sum of the force is equal to 0. Stage 2, if it's in motion, so it continue in motion with a constant velocity, unless any external force, it try to stop it, it try to change it motion. So, and unless the external force, it comes and acts this motion. So that is about the first Newton law. And sigma f is equal to 0, so that means x-axis, up and down. X-axis, so means up, down. That is y-axis. X-axis, left and right, all is equal to 0, and we give more explanation about this, and we give more examples about this step. Then last lecture we discussed about Newton's second law. Newton's second law. Second law. So, and we discussed this law, it make a relation between the acceleration and the applied force. And there is a relation between the acceleration and the applied force. If the applied force is more, so that means the acceleration is more. If the applied force is less, so the acceleration, it will be less. What kind of relation is this? It is proportional direct. That means if any one increase, the other it will be increase. If decrease, it will be decrease. And also there is a relation between the acceleration and the mass, and it is proportional inverse. So the acceleration in Newton's second law equal to F divided by m. From this equation we can find the F is equal to ma. It is a very important law to solve many equations. And we know the acceleration is a vector quantity, and we know why it's a vector quantity, because it depends on the magnitude and the direction of the object. And the acceleration, it is also vector quantities, because it depends on the magnitude and the direction. So that is from the previous lecture. Our lecture today, it is about the friction force. What is the mean of the friction force? When the surface is slide or tend to slide over one another, the force of friction it will be acts. عندما يكون السطح ليس ناعم أو مش أملس، فتظهر عندنا قوة. هذه القوة تعمل على إعاقة حركة الجسم، وهي تكون دائما عكس اتجاه القوة. فمثلا إذا كان عندنا هذا السطح، عندنا بوكس، هذا البوكس أثرت عليه بقوة applied force في هذا الاتجاه، ولكن السطح اللي أنا بأثر فيه سطح خشن، it is not soft. إذا راح تظهر معانا قوة تعمل على إعاقة هذه الحركة في هذا الاتجاه، القوة في هذا الاتجاه. القوة التي تعمل على الإعاقة راح تكون في هذا الاتجاه، تسمى بفراكشن فورس. وهذه القوة تكون دائما على طول خط القوى. إذا the friction force, it is the force which comes to act along the direction of the tangential to the surface in a constant opposite of the motion، ودائما تكون عكس اتجاه الحركة. So that is the friction force. And the friction force, I upload for you one document with some exercise, with some problems, and you can try to solve this problem. The friction force, there is a constant. This constant, it depends on the surface. So for each surface, لكل سطح له قوة احتكاك معينة. هذه قوة الاحتكاك تختلف من سطح إلى آخر. فيرمز لي معامل الاحتكاك بالرمز ميو. It is a constant value of the friction surface. Friction surface, and it's not fixed. It is different from one surface to other surface. And F as a friction force, in some references it's written as Fs. In some references, in our references, we write it F fraction, F small f. It's equal to mu. But here we discussed as 100, we discussed about the statics fraction. So F s mu s and multiply n. N is the normal force that apply to the object. I give you one example, and the others it is in your document. So here the example, a block of 10 kilogram is pulled at a constant speed on a rough horizontal plane by the force of 20 newtons. So I have a block of 10 kilogram is pulled at a constant speed, so that is the mass, on a rough horizontal plane by the force F is equal to 20 Newton. Calculate the coefficient of the fraction. So what he want mu. How much? So how I can find mu? Mu, you can find it from the question, and it depends on the surface. So we want mu, this mu from these variables. So how we can find it? By using this equation. The normal force, as we mentioned about it in first lecture when we go to the forces, it equal to the mg. It is the weight force. The weight force. The fraction force is equal to the constant, the coefficient. That is the coefficient of the fraction. I write it, the coefficient of the fraction. He wants the coefficient. This is the coefficient. So how we can find it? We find it from this, because each surface have a different coefficient. So the important notes, M, the force applied, F, and we want mu. So how we can find it? I open a new page. It is nice to open a new page. So the information that I have, a block of 10 kilogram, so that is a mass, M, is pulled at a constant speed on a rough, so that means it is not slide surface, it is rough, خشن, not soft, by the force. So F is equal to 20 Newton. What is the question need? Mu. It is the coefficient. The coefficient. So how much the coefficient? I know F fraction is equal to the coefficient normal force. Normal force, it is the weight force. So mg. Okay. How I can find it? Mu is equal to F fraction divided by N. How much the F applied, or F net here, applied force, FP, sorry, applied force. So how much applied force? 20. The normal force, 10 multiply 9.8, because here mg, that is m and that is g. So mu, it's equal to F 20 Newton divided by 89 or 98, so it's equal to 0.204. Be careful, the coefficient of the fraction without unit, it's only number. So that is one of question. And I upload for you some questions in your model by Word document, and you can try to go through it. So that is about the friction force. It is the force that it resists the object to move with the direction of the applied force. Then from Galileo that we discussed before, Galileo founded both of concepts. So Galileo finds the both of concepts of inertia, that is the amount of the object to resist the change in its state, and the acceleration. But he could not explain it. فغاليليو وجد الأشياء الهامة، وجد القصور الذاتي المعتمد على الكتلة، لأن القصور الذاتي هو مقاومة الجسم لتغيير الموقع وتسارعه، وجدهم فعلا، ولكن لم يستطع أن يعطي شرح مفصل أو يعطي تفسير معين للأوبجكت mass feel with the equal acceleration. ولكن لم يعطي أي تفسير بأنه الكتل المتساقطة تسقط بنفس التسارع. لكن نيوتن في قانونه الثاني أعطى هذا التفسير، ووضح بأنه هذه الأجسام بكتلها المختلفة، سواء كانت كتلة كبيرة أو صغيرة، فإنها عند سقوطها سوف تتسارع بتسارع وحيد، وهو ما يسمى بالجاذبية الأرضية. So that it proof the discovered of Galileo that is any object it will be it fails under the acceleration of the gravity. يعني هذا تؤكد النظرية جاليليو بأنه إذا سقط جسمين بكتل مختلفة، مثل فيل وفار، فيل شاحنة وسيارة، فراح تصل إلى سطح الأرض بنفس التسارع، هو فسرها مش بتسارع، هو فسرها بسرعة لكل ثانية، يعني في كل ثانية راح تزيد سرعة متر بير سكند يعني كل ثانية لكل ثانية راح تتحرك في نفس هذا وهو التسارع. فنيوتن فسرها تفسير علمي بأنه هذه مثلا الكتلة، إذا كان عندك كتلة mass with 200 kilogram, it fail with a free fall, and another mass with 2 kilogram. All of these two, it reach the ground with the same amount of acceleration. راح تسقط إلى الأرض في نفس الوقت. ليش؟ لأن تأثر عليه تسارع واحد، وهو تسارع الجاذبية. فالإفنت هنا كم القوة المؤثرة؟ عندك القوة المؤثرة هي قوة الجاذبية، قوة السحب drag force، وتسحب من؟ تسحب الكتلة. طيب من التسارع، أنا قلت لك اهتم بالقانون، التسارع ماذا يساوي؟ عبارة عن القوة اللي هي Fg على الكتلة M. Fg بكم؟ الFG عبارة عن M في G على M. لو تلاحظ الM تروح مع الM، بس ما نستعجل، نفترض أنه ما عرفت أنا الM راحت مع الM. So M how much? 2 multiply the gravitation, it's 9.8, but for questions and for just only to calculation we used it 10, but it is not 10, it's 9.8. فقط الاستخدامات للتسهيل for make it easy to remove the numbers for calculation. Divided by the mass 2. so it's equal to 20 divided by 2, so it's equal to 10 meter per second square. So that is for the small mass. For example, m2. That is acceleration for m2. Acceleration to, okay, acceleration to a1. It's equal to F net divided by the mass. F net is equal to what? mg divided by m, equal to m 200 multiply the acceleration 10 divided by 200 m. So 200 moves with 200, so it's equal to 10 meter per second square. So this result is the same of this result. So all these objects, it reach the ground with the same amount of acceleration. So any question? I hope that all think it will be clear. So the acceleration in free fall is independent, مستقل of an object masses. In the case where the air resistance can be neglected, but it's necessary to know the air resistance, the wind, the other thing that it will be effect, it is neglected. The net force is a weight because it is only the force that can be taken. So the acceleration, it's equal to the F net divided by the m. So the F net is equal to m. If we have the air drag, قوة السحب, it is the force that arising from the air resistant. هي قوة السحب التي تقاوم الهواء, air drag. So when it equal to 0, so that means the object it accelerate under the gravity only. So we can explain this in this figure. So here, if you check here in number 1, so what is the drag force? So in number 1, R is equal to 0 because there is no force for the air, because in number 1 F air is equal to 0, so that means the R, the air drag, is equal to 0. So what is the net force? F net, it's equal to W, the weight. So what is the weight? mg. So here is 0. Here is the mg. So the F net is equal to the Fg. So it moves with the acceleration, so it equal to 10. We can prove it, and we find it from our equation. Okay, no problem. F acceleration is equal to F net divided by m. So it's equal to mg minus the drag force R divided by m. So here it's equal to 0. 0. So that means mg divided by m. M is moving with m, so the acceleration is equal to 10 per meter square. 10 meter per second square. So that is in number 1. A is equal to 10 meter per second square. Okay, number 2. Number 2, you can check the F air how much? F air 350. So what I do, just put the numbers, put the value, no problem. So that is for number 1, the acceleration is equal to 10, and we explain it. Diagram P, so the acceleration how much? We can find it. So F air is equal to 350, as it mentioned here, Newton. That means the R, the air drag. So put it in your equation. A is equal to mg minus r divided by m. Open it in mathematics, how you can open it. So mg divided by m minus rm. Put the values. M of the skydiver is 83.3. It's given in the question. Multiply the gravitation, we assume it 10, divided by m of the skydiver, 83.3, minus r is the F air, 350, divided by the mass of the skydiver, 83.3. So the acceleration, it's equal to 5.8 meter per second square. I explain it in Arabic. The F air اللي هو قوة الهواء هي نفسها قوة السحب. في الدايجرام A قوة السحب اللي هي FR 0 ما معطى، إذا عبارة عن 0. F air 0. So that means R 0. فلما طبقنا القانون أنه الM اللي هي كتلة سكاي دايفر في الجاذبية اللي افترضناها أنها 10 متر بير second square G, we assume it, and it is exactly 9.8 meter per second square, but we assume it because we want to make easy calculation for the numbers، فقط لعملية اختصار للأرقام. فطلعت عندنا الاكسلريشن هنا 10. طيب نطبق هنا إذا كان في قوة سحب. So فسكاي دايفر هير الحين عنده قوة هواء تقاومه، مقدارها كم؟ 350. إذا هذه عبارة عن R. وفي قوة جاذبية إلى الأسفل مقدارها وزن الجسم في الجاذبية اللي هي 833، لأن وزنه 83.3 في الجاذبية 10 تعطيك هذا الرقم. طيب طبق العلاقة اللي درسناها قبل شوية، العلاقة هذه the acceleration is equal to F net. F net معناها القوة المحصلة هي عبارة عن قوة الوزن ناقص قوة السحب اللي هي F air. رياضيا البسط مقسوم على الطرفين M G على M ناقص R على M. في حالة أنه الجسم بإمكانك تختصره أو بإمكانك تبقيه up to you. إذن فعندما يكون هذا المقدار يساوي الصفر فيعطي الجاذبية فقط لا غير. فتكون التسارع يساوي الجاذبية إذا كان F air the air resistant or drag force air drag or R equal to 0 فقط لا غير. بينما إذا كان له قيمة فراح نجد القيمة مثل ما الآن بنجدها في المسألة الثانية في diagram P. Okay, in diagram C just applied use the information. So here number 2 the acceleration A is equal to 5.8 meter per second square. Then I want to check it in. الحين نقربها على C. So that is in C now. طيب F air is equal to come how much? 700. This is R. So put it in your equation. mg على m ناقص rm. طيب mg بكم؟ هذه أحسن أن نختصرها. إذن أحسن أنه نختصرها على أساس تكون عندنا سهلة. m تروح مع الm إذن هذه تبقى g ناقص r بكم؟ 700 على m سكاي دايفر ماس 83.3. إذن كم تعطي؟ g عرفناها 10 ناقص 8.4. So the acceleration it's equal to 1.6 meter per second square. So in this point here the acceleration of effect or depend or keeps the skydiver to move down A is equal to 1.6 meter per second square. إذن التسارع الذي يؤثر على هذا الشخص المظلي راح يكون قيمته 1.6. لاحظ بأنه be careful. لاحظ بأنه عندما كان صفر إذن يتحرك بتسارع الجاذبية. عندما كان هناك تأثير في قيمة لل F air or the air drag so it becomes less. When the value of F air is more so it becomes more less. Now the fourth diagram, diagram D, when the F air or R is equal to the Fg. What is the acceleration? So in this kind, the object still not moves because two forces equal in magnitude, opposite in direction. This resists the object to move down. This moves the object to fill down. في قوة تسحب الجسم إلى الأسفل وفي قوة تقاوم عملية سحب الجسم إلى الأسفل. إذا كانت هذه القوتين متساويتين في المقدار ولكن متعاكستين في الاتجاه، هذه تعمل على إبقاء الجسم في الأعلى وهذه تعمل على سحبه إلى الأسفل، فراح يبقى الجسم في النص، لأنه جي راح تكون هي الأي، إذا راح تكون equal to 0. فراح نكتشفها. we prove it. So we prove it. That means the acceleration in this position is equal to 0. So number D, just write your values and put it in your equation. استخدم المعطيات وحطها في المعادلة. طيب D, the F air or R, it's equal to 833 Newton. Okay. I put my equation. Here is G minus FR, how much? 833 divided by the mass of the skydiver, 83.3. So here G is equal to 10 minus this equation, this calculation, 10. So 10 over 10 minus 10, it's equal to 0 meter per second square. So from Newton's second law, the acceleration of the gravity is equal to the acceleration of the object when R is equal to 0. The air resistance or the force of the air equal to 0. So from Newton's second law, we find that only the acceleration is equal to G only if F air or R is equal to 0. So that is the important thing in this lecture. So I hope it is clear. Try to do the best to choose another values in these examples. Maybe you can here check the force of the air to 200 Newton and check what is the acceleration. Here put it 400 and check the acceleration. Here you can put it, for example, 600 Newton and check the acceleration. So that is for today. I hope the lecture it will be clear and all think it's easy for you. And please, if there is any question, you can ask me in the lecture on Sunday, inshallah. Okay, thanks a lot and see you.